Okay, so the last and final type of factoring is what we call factoring by grouping. Factoring by grouping is only used whenever there are 4 terms. So when we did basic factoring and the slip and slide, that was whenever it was a trinomial, which is 3 terms. But we're talking about factoring by grouping when there are 4 terms. So if I look at this first example at the top, notice there are 4 terms: x cubed, 7x squared, 2x, and 14. And grouping is rather easy, so let me just jump right in. The steps when you are factoring by grouping is first we are going to group the first 2 terms. So I'm going to put a set of parentheses for the first 2 terms. And then the last 2 terms. Notice when I group the last 2 terms, I also include the sign that that third term is. So include the positive, and you'll see why in a little bit. Okay, now I'm going to treat this like 2 binomials. So x cubed plus 7x squared is one binomial, and then 2x plus 14 is the second. What we're going to do is find the GCF of each set of binomials. So for this first binomial, the GCF of x cubed and 7x squared, they don't have a coefficient, but they do have a variable x, and the smallest I can bring out is 2, because I can bring out 2 from 3 and 2 from 2. Then I write down what I'm left with. So x cubed divided by x squared is just x. 7x squared divided by x squared is positive 7. All I've done is taken the GCF out of that binomial. So now I'm going to take the GCF out of 2x and 14. 2x and 14 have a GCF of positive 2. Notice I do bring that positive 2. So then I look at what's left. 2x squared divided by 2 is x, and 14 divided by 2 is positive 7. And I want to point something out. This is what should happen if factoring by grouping is done properly. If I look at it, x plus 7 and x plus 7 are exactly the same. And that's what we want to happen whenever we are factoring by grouping. So what I'm going to do now is what my GCF was from both terms becomes one binomial. So x squared plus 2 is one set of binomials. And then since x plus 7 and x plus 7, they have that in common, my second binomial is x plus 7. And that's it. That's my answer. This is how you factor by grouping. Now, if I want to check my answer, I'm going to use the FOIL method. So first, outer, inner, last. X squared times x is x cubed. Outer, x squared times 7 is 7x squared. Inner, 2 times x is 2x. And last, 2 times 7 is 14. And if you notice, I end up back at what I started with my original problem. So let's just practice this, okay? So first, I check, it is 4 terms, so that means I'm going to factor by grouping. Okay, break it up into 2 binomials, include the sign that's in front of the third term, just FYI. All right, so my GCF of 3x cubed and 15x squared, 3 and 15 have a GCF of 3, and x cubed and x squared have a GCF of x squared. So when I break this up, 3x cubed divided by 3x squared is just x, and 15x squared divided by 3x squared is positive 5. My GCF of negative 2x and negative 10 would be negative 2. Okay, not just positive 2. So negative 2x divided by negative 2 is x. Negative 10 divided by negative 2 is positive 5. And the reason why it's important to bring out the negative 2 and not just a positive 2 is because if you pay attention to my signs here, I want them to be the same. So if I just brought out a positive 2, then this would be minus 5, and I don't want minus 5. So now that I've verified that my 2 binomials inside the parentheses are the same, I'm going to bring together my GCFs. So 3x squared minus 2 is my first binomial. And since these are the same, I'm just going to write it once. My second binomial is x plus 5. Let's keep doing it. So I'm going to break this up into 2 binomials. 8x squared plus 12x, the GCF of 8 and 12 would be 4. And the GCF of x squared and x would be x. So if I look at it, 8x squared divided by 4x is 2x. 12x divided by 4x is positive 3. On the right side, my GCF of 2 and 3, there isn't a coefficient that they have in common. So, I mean, technically it's 1. Okay, and then x, they don't have an x in common. They do have a y in common, so I'm going to bring out that y. And then what I'm left with, 2xy divided by 1y is just 2x, sorry. And then 3y divided by 3 is positive 3. Notice my binomials are the same, so I did it correctly. 4x plus 1y is my first binomial, and then 2x plus 3 is my second. Normally we won't see too many where there's x and y, like two different variables. So let's practice some basic ones. So the GCF of x cubed and 2x squared is x squared. X cubed divided by x squared is x. 2x squared divided by x squared is positive 2. My GCF of negative 5 and negative 10 would be negative 5. Again, I want to bring out that negative because negative 5x divided by negative 5 is just x. Negative 10 divided by negative 5 is positive 2 because I want my signs to match up. So then I bring my GCFs to make my first binomial. And then my second binomial is x plus 2. Number 4, break this up into two binomials. X to the fourth plus 4x cubed have a GCF of x cubed. X to the fourth divided by x cubed is x. 4x cubed divided by x cubed is positive 4. My second GCF, 2x and 8 have a GCF of positive 2. So 2x divided by 2 is x, and 8 divided by 2 is positive 4. Notice my two binomials are similar. So my GCFs together make x cubed plus 2. And then my second binomial is x plus 4. I'm practicing some more with multivariables. 6y squared and negative 3y have 3y in common. 6y squared divided by 3y is 2y. And negative 3y divided by 3y is minus 1. Okay. The GCF of 2yz minus z is just a z. And I'm going to go ahead and make it positive z. So 2yz divided by z is 2y, and negative z divided by z is negative 1. And if I look at my GCF, or my two binomials, they are similar. So 3y plus z and 2y minus 1. Don't stress too much about multivariables because you won't see too many of those, but it's good to practice. So if I look at this one right here, x squared y plus 3x squared, the only GCF they have is x squared. X squared y divided by x squared is y. 3x squared divided by x squared is positive 3, just positive 3, sorry. On the right side, negative 7y squared and negative 21y, the GCF is negative 3y. Negative 7y, not 7, sorry, negative 7y, because 3 doesn't go into 7. Negative 7y squared divided by negative 7y is just y, and negative 21y divided by negative 7y is positive 3. Again, my two binomials match up, so my GCFs are x squared minus 7y, and then my second binomial is y plus 3. Just to practice some more with multivariables, so this first one not so much. If I look at combining those by grouping, 10x cubed and negative 25x squared have a GCF of 5x squared. 10x cubed divided by 5x squared is 2x. Negative 25x squared divided by 5x is negative 5. On the right side, the GCF of 4x and negative 10 is positive 2, because 4x divided by 2 is 2x, and negative 10 divided by 2 is negative 5. My binomials match up, so I'm going to group my GCFs together. 5x squared plus 2x and 2x minus 5. Number 8. So 2x squared y and 6xy have a GCF of 2xy. So 2x squared y divided by 2xy is just 1x. 6xy divided by 2x is just positive 3. I do not want this leading coefficient to be a negative 1, so the GCF of negative 1x and negative 3 would have to be a negative 1. Negative 1x divided by negative 1 makes it a positive x, which is what I want to happen, and negative 3 divided by negative 1 is positive 3. Now I have my two binomials the same. I'm going to bring my GCFs together. So 2xy minus 1 is my first binomial, and x plus 3 is the second. Okay, over here, 6m and negative 9m have a GCF of 3m. 6mn divided by 3m is 2n. Negative 9m divided by 3m is negative 3. On the right side, I don't want negative 4 to be a leading negative, so I'm going to bring out GCF of negative 2. Negative 4n divided by negative 2n is 2n, and 6 divided by negative 2 is negative 3, which makes my two binomials the same. So my GCFs make my first binomial 3m minus 2, and then my second binomial is 2n minus 3. Just going to keep going. All right. A cubed and a squared b have a GCF of a squared. A cubed divided by a squared is a. A squared b divided by a squared is positive b. On the right side, ab and b squared have a GCF of positive b. AB divided by b is a, and b squared divided by b is positive b, which I end up with the same binomial. So my GCFs form together to make a squared plus b, and my second binomial is a plus b. Two more. So 4r squared s and negative 8rs have a GCF of 4rs. 4r squared s divided by 4rs is just r. Negative 8rs divided by 4rs is negative 2. On the right side, I need to pull out a negative because I don't want my leading coefficient to be a negative. So negative 3r and 6 have a GCF, oops, forgot to write it, of negative 3. Negative 3r divided by negative 3 is r. And 6 divided by negative 3 is negative 2, which my binomials end up being the same. So my GCFs together form 4rs minus 3. And my second binomials are minus 2. Okay, 12. So my GCF of x squared y squared minus 3x squared is x squared. X squared y squared divided by x squared is y squared. Negative 3x squared divided by x squared is negative 3. On this side, 2y squared and negative 6 have a GCF of 2. 2y squared divided by 2 is y squared. And negative 6 divided by 2 is negative 3, which my binomials end up being the same. So I'm going to bring my GCFs together, x squared plus 2 and y squared minus 3 to make my second binomial.